Hey everyone, it's Yandar, the science guy from the Great Lakes Science Center, and today we're talking about NASA's plans for deep space exploration. I'm talking about crewed missions to the moon, near-Earth asteroids, and one day, even Mars. Joining us from NASA's Johnson Space Center in Houston, Texas today is our subject matter expert. She is an extraordinary woman who travels the country integrating human exploration resources at science centers, libraries, all across the United States. Our guest presenter currently serves as a communications strategist and museum liaison for NASA's Artemis program. Please welcome my very good friend, Patricia Moore. Patricia, thank you so much for joining us. We are so very excited to have you with us.
Awesome. Well, thank you so much for having me. I'm very excited to talk with you and all of your campers this morning and share what NASA is doing to get humans back to the moon and onto Mars.
Very cool. Well, I know that our campers have lots of questions for us, but I think they really aren't sure of what Artemis is. Do you have a few moments to tell us more about the Artemis program?
I do. I'll spend probably maybe about 15 minutes showing you some great videos and pictures about Artemis and about our plans for Mars, and then I'm happy to answer any of your questions.
Wonderful. Thank you so
much. 50 years ago, we went to the moon. We called it Apollo.
What many people don't know is that Apollo had a twin.
She was a woman named Artemis,
goddess of the moon.
We are returning to the moon
as a new generation of explorers.
This time to stay
and to prepare to achieve humanity's next giant leap of sending the first human missions to Mars.
We believe our course will redefine what is possible.
That we would discover life-saving,
earth-changing science.
And that the challenges ahead will inspire generations.
This is our manifest.
For all who wondered if we could return.
For all who dreamed of pressing beyond.
This is your calling.
We go for all of America.
We go.
We go as the Artemis generation.
We go.
All right. Well, again, thanks for having me. My name is Patricia Moore. I work at Johnson Space Center, and I absolutely love being part of the Artemis communication team, where our job is to go across the country to do things virtually, social media, websites, any way that we can share NASA's story. That's what we do. And here's a few pictures of me having a lot of fun sharing NASA's story just a few years ago. And I can't wait to get back on the road and do it again, hopefully in the next, several months. All right, so let's jump right in and let's talk about Artemis. So Artemis is a series of missions that will send the first woman, the next man, as well as the first person of color to the moon in just a few years. So it's very exciting. And Artemis, of course, is the twin sister of Apollo. So it really is the perfect name for our next phase in lunar exploration. Now, there are lots of reasons to return to the moon. If you ask our scientists and our research team at NASA, they are really excited about studying the moon in a new location, using the moon as a way to explore and understand our solar system. And one of the most exciting pieces of research we want to do is to understand where the water came from. We want to understand the volatile cycle. And we know that there's water, frozen water in craters on the moon, and we want to be able to extract it and use it as a resource, but then also understand where it came from. On my team, we're on the human exploration and operations side of NASA. We're interested in how do we live on another world. So we're going to have to build spacesuits and rovers and habitats and tools and environmental control systems and waste management systems. You think about all the things that you need when you go camping. Imagine having to take all of that with you to the moon, as well as all of your oxygen, and knowing that you can't get to a store anytime soon. So we want to use the moon as a test bed and a place to test all of our technology and systems before we go to Mars. So we're headed to the South Pole region of the moon, which is an area humans have never explored. This is a time-lapse video from the Lunar Reconnaissance Orbiter showing us what the South Pole region looks like. And there are two things I want to point out. The first thing I want you to notice is the permanently shadowed crater regions. Those are the really, really dark spaces. And that's where we know the water ice is. And then if you also notice around the rims of the craters, you'll see that it's almost in constant sunlight. And this is really important because we can't set up an Artemis space in a dark, dark crater. It's not safe for lots of reasons. And so we want to be near the craters, but not be in total darkness. And so those areas of light is where we're going to set up our base. Now, I don't know the first landing site of our Artemis missions yet. We'll hopefully find out that location in the next year. So stay tuned, but it will probably be somewhere in this picture here. Now, I like to talk a little bit about the engineering of our vehicles because that's important. There are so many different rockets and spacecrafts in existence right now. There are quite a few that can take astronauts and cargo to the International Space Station, which is in low Earth orbit. But we don't have a vehicle that can go to the moon. We cannot use the space shuttle. We can't use the Soyuz rocket. We can't use the Dragon and the Falcon. We can't use any of these vehicles because they're designed for low Earth orbit. So we have a saying that mission needs drive design, which means you design your rocket and your spacecraft based on the objectives and the destination of your mission. So for instance, if we're going to the moon or even to Mars, you'll notice that we're going to be traveling at faster speeds. We're going to be much, much farther away from the Earth. The moon is 3 to 4 days. Mars is 9 months on average. And our reentry heat is even more intense. And so we go from about 3,000 degrees all the way up to doubling that, 6,000 degrees when we re-enter Earth. So we need a new type of spacecraft, a more robust spacecraft that can handle all of these challenges of traveling far away from Earth. And the Orion spacecraft is the answer to that challenge. And Orion is going to ferry or carry astronauts from Earth to lunar orbit. Has 3 main parts. It has the crew module where the astronauts live, and they can live there for several weeks. We usually will most likely take 4 astronauts at a time, and they can, this spacecraft can accommodate short astronauts as well as really tall astronauts. The power part of the Orion is the service module, which is the back end with the solar panels. It's built by the European Space Agency, who's our first partner in our Artemis missions. And then the top little part is what I call the pencil rocket, although it's much larger in real life than a pencil. It's the launch abort system, and that will pull the crew and their spacecraft away from the larger rocket during launch if there's a problem and the crew is in danger. Now, Orion for the first Artemis launch is already finished. It's built and it's sitting at Kennedy Space Center right now, and we are going to attach it to the Space Launch System rocket soon. So this is the rocket that will carry astronauts to the moon and beyond. And it will be the most powerful rocket we've ever built, the most powerful rocket in the world, even bigger and badder than the Saturn V that took the Apollo astronauts into space, into the moon. And remember, this is designed for deep space, not to go to the space station. This is made to go away from Earth. It has enough power and enough thrust to get away from Earth's gravity. And you can kind of see the comparisons between the SLS or the Space Launch System rocket here and maybe some other rockets that you're familiar with. Now, the SLS rocket is sitting at Kennedy Space Center, or it was sitting at Kennedy Space Center about 2 to 3 weeks ago outside the building. And recently, in the last couple of weeks, we've brought it in the vehicle assembly building. We hoisted it with cranes, and then we lowered it in place and are attaching it to the solid rocket boosters. So this is the real thing. This is the real rocket. And we're going to launch this baby in just a few months. We're still working towards a November launch date for our Artemis 1 mission. And what's really cool about the rocket is we have to be able to get it out to the launch pad, right? It's in this building and it's being built and assembled. But while we're assembling it, we're building it on top of a mobile launcher. And that's the structure you see there on the road. So once it's built and it's attached to that mobile launcher in the building, there's a crawler underneath that platform, and it will drive the rocket out to the launch pad at about 1 mile an hour. And then once the mission's over, Orion splashes down in the Pacific Ocean off the coast of California. So Artemis 1 is happening in just a few months. We're still, like I said, we're working towards November. So I want to show you guys a video that talks a little bit about Artemis 1 and what we can expect for future Artemis missions as we prepare to go to the moon and eventually onto Mars.
3, 2, 1, 0. Ignition. Liftoff.
Artemis 1 will lift off from Launch Pad 39B at NASA's Kennedy Space Center in Florida with 8.8 million pounds of thrust provided by the most powerful rocket in the world, our Space Launch System rocket, or SLS. The uncrewed flight will be the first integrated test of SLS, our new Orion spacecraft, and exploration ground systems at Kennedy. Artemis 1 will send Orion beyond the moon, 280,000 miles from Earth, farther than any human spacecraft has ever flown.
This is not NASA doing this. This is the United States of America doing this program, the Artemis program. And there are companies all across our country that have a part in it. So there is kind of this wave of excitement being generated just by saying, we're going back to the moon.
After the upper stage of the rocket separates from Orion, the upper stage will deploy small satellites over several days to perform science experiments and technology demonstrations. Orion will make its multi-day outbound trip to the moon, propelled by a service module provided by the European Space Agency. Engineers will test Orion's systems on the way to the moon. Then, Orion will fly about 60 miles above the lunar surface, using the moon's gravity and engines on the service module to enter a lunar orbit. After about a month and a total distance of over 1 million miles, Orion will return home, faster and hotter than any spacecraft has before. A primary goal of Artemis 1, ensure Orion safely returns to Earth before we fly with humans. When we do, we'll build our capability for sustainable lunar exploration, preparing us for missions farther into the solar system.
Initially, what we'd like to do is start establishing a presence on the moon. So we're going to establish going back there on a regular basis, and then we'll end up setting up Gateway, and we would launch to the Gateway, and from Gateway land on the surface of the moon.
We are there for weeks, months on end, and there we're going to be able to test out all the hardware and the habitats and the hatches and the suits and the rovers that'll allow us to prove out those technologies. The moon will lead the way to Mars, and we should be there within the next couple of decades.
So that's really exciting to think that we're launching our first mission in just a few months. And then from there, about a year or so later, we'll have our Artemis 2 mission, which will send crew to the moon, and we're going to orbit the moon and then come back. So this will be a flyby mission and a chance for astronauts to work and live inside the Orion spacecraft in space for the very first time. So it's like one final test before we then have our next mission, which will send the next man, the first woman, and the first person of color to the surface of the moon, which is really exciting. And here's a look at our current astronaut, our team. And we've got so many different astronauts from different backgrounds and skill sets. We have medical doctors, we have surgeons, we have many different kinds of engineers. So you can have like mechanical or aerospace engineers. We have pilots that come from the military. And then we also have many scientists and researchers. So it's going to take a very diverse skill set and talent group to be able to have successful missions to the moon, because we're going to need astronauts that are capable of fixing things when things go wrong, flying the spacecraft, doing research, and maybe handling medical situations. And so we've got a really great diverse group of astronauts that are a part of our Artemis team. Now, when it comes to getting to the surface of the moon, we're going to need something other than a rocket and the Orion spacecraft. We need a human lander. And NASA's been working with industry, so companies out in the United States, to come up with designs on how to get astronauts to the surface. And so we sent out a kind of like a competition, or we call it a procurement, and all these different companies submitted proposals and wrote down all of the the schematics and the designs of how their company would build a lander to get astronauts safely to the moon. And then NASA picked the top 3. So these are the top 3 companies and groups that are working, that will hopefully all get to work with NASA one day. But we will, by the end of August, choose one of these companies to be that first group that sends humans to the surface. And then NASA wants to continue working with companies just like these to build landers for future missions. So the Gateway you learned about in the video, remember it's an orbiting platform. It's a spaceship that orbits the moon. It doesn't fly off to Mars and it doesn't fly to Earth. It stays in orbit around the moon. And this is a great place for astronauts to fly and rest and be there for a little while before they take their mission to the surface of the moon. So you can see that Orion is attached in this picture, a mock-up of a lander. And then we have a very, very small habitat that the astronauts can live inside before they make their journey to the surface of the moon. Now, what's really cool about Gateway is it's exciting in that we have international partners in other countries that want to be a part of this piece of Artemis. We have the Canadian Space Agency that's going to build a robotic arm for the Gateway, and then the Europeans and the Japanese space agencies are interested in building an international laboratory to do science in orbit around the moon. And there are lots of other countries that want to partner with NASA as well. We've got United Arab Emirates, we've got Israel, we've got New Zealand and Australia and South Korea and Brazil, just to name a few. And so our team of partners is growing the farther and the closer we get to these first missions. Once we're on the surface, we've got lots of work to do, testing out habitats, spacesuits, rovers. We want to learn to live on this world so that we can prepare for Mars one day. Now, we're not ready to go to Mars. It's going to be at least 20 years, most likely, before we get there. We don't have an exact date on when that's going to happen. But in the meantime, we'll continue to send robotic explorers to Mars and help us understand the red planet, what the atmosphere is like, the ground, understanding its composition so that we can better prepare for our human missions. And what's really great for you, all of you, is that you're the perfect age to be a part of Artemis and be a part of our Mars missions one day. You could be one of those first astronauts to set foot on the surface of Mars, look up at the night sky and see Earth about 39 million miles away. So it's a tiny little speck in the sky, just like Mars is when we're looking at it from Earth. And it just really puts in perspective how challenging these missions are going to be and how important Artemis is in preparing us for traveling to Mars. So if you want to be a part of NASA, there's so many different career opportunities for you. There's also lots of industry partners and companies that work with NASA that you can also work for, have a career with. And so here are just a few. Food scientists working at mission control, building the actual rocket and the spacecrafts with your hands. So manipulating with welding and other technologies to connect everything. Coming in as a NASA intern in college is a great way to get experience. We have scientists and researchers and geologists and engineers that build spacesuits and robots. We have astronaut trainers that teach them how to do spacewalks and even how to use the toilet in space. And then we have people that are non-traditional science and engineering and technology jobs. People like me who work in communication and public outreach, social media. We have graphic artists, all sorts of artists and video editors and TV production crews. So many different types of jobs and careers, and all of these talents are needed because exploration is a team sport. It takes all kinds of people from all over the world to make spaceflight possible. So with that, I would love to answer your questions about Artemis, about the moon and Mars, and just in space in general.
Wow, I have to tell you, that is so very, very cool. We've got quite a few people who have joined us. There are 6 classrooms of our campers that are with us today. Plus, we have some camp at home students that are watching as well. I've got some of their questions. Right. And if you don't mind taking a moment to answer some of them, I've got some great questions here for you. From our kindergarten class, one of the questions that they have is, what does it feel like in space?
Well, you have to remember that I've never been to space. I'm not an astronaut, but I can tell you what astronauts say. When they go into space, they immediately are weightless, right? And your body immediately begins to change when you're in weightlessness. Your fluids in your body shift and they move to the top of your body. It can be disorienting because you can maybe dizzy because there's the fluid in your ears and your vestibular system that's very confused. That's your balance system in your body. And sometimes astronauts get motion sickness and they don't feel so great the first day or so. But once they're used to being in space and their body adapts, which is actually pretty quick, it's so much fun. The astronauts love to soar through like Superman or, Supergirl through the modules of the space station. And it becomes like second nature, like they were born in space. And so our bodies adapt pretty quick, but it can be kind of rough and uncomfortable for some, not all, at the beginning. Great question.
Wow, thank you so much. Now, I've got a question from our 4th and 7th grade classes. Similar question. They'd like to know, how big will the rockets have to be to go to the moon, and will those rockets have to be bigger if we want to go to Mars?
That's a really great question. And the answer is it doesn't necessarily have to be bigger. So the Space Launch System is a very similar size to the Saturn V. And the Saturn V rocket that we used during Apollo was 363 feet long. And so the SLS rocket is very similar, but it's more powerful, which means it has more fuel and more thrust capability. So that's kind of the size that you're looking at, but you can add a section on top that allows you to carry more stuff. And so you have a basic rocket that can carry, let's say, 12 elephants into space. And then we can design what we call an exploration upper stage, which is something we want to do that allows us to carry really big habitats and really big rovers and a lot more supplies. And so it won't be taller, but it might be wider in some sections. Great question.
Oh, wow. That is really, really amazing. Now, I've got another question here for you. This one is from one of the students that's in Miss Mary's 3rd grade class. They want to know, how do you keep air inside the spacecraft?
That's another great question. So I want you to think of it like a balloon. Okay. Now, of course, the spacecraft isn't made of rubber, right? Or latex, but think of it like a balloon where you can put air inside of an object and it stays inside because you have a barrier all around it. A lot like an airplane. If you've ever flown in an airplane, the airplane team or the crew pump air inside of the aircraft, right? And so that we have a clean and fresh air to breathe. The higher you get in the atmosphere or when you're in space, the less oxygen there is. And so they have to have air on the airplanes as well. So in space, they have something, I like to call them cans. They look like big, giant cans. They're modules or sections of the space station. And we pump air. So we have tanks full of air that we use to pressurize. That's the word that we call putting air in something, pressurize the space station. And then because it's all enclosed and there are no holes, the air stays inside. So as long as the structure of the space station isn't compromised, which means as long as there's not a hole in it, the air will always stay inside of the space station. Great question.
Thank you so much for answering that. I made a mistake. I thought that came from Miss Mary's 3rd grade class. That was actually a question that came from Miss Megan's 1st grade class.
Oh, it's a great question from a 1st grader.
There you go. Now, here's the question that should have been for Miss Mary's 3rd grade class. Students there want to know, how long does it take to get to Mars?
So we'll start off small. It takes 8.5 minutes to get to Earth orbit, just an orbit around the Earth, 250 miles. And then if you want to go to the moon, that's 3 to 4 days. And then from Mars, you're looking on average 8 to 9 months. And so it really depends on how the planets are orbiting the sun and how they're aligned, how close they are when we launch, and how far away, we have to catch up to Mars before we get there. But you're looking at a minimum about 6.5 months to up to on average 9 months. So it's a really long journey.
Wow, that really is a long time. I've got a question here. This one comes from Miss Sarah's 1st and 2nd grade classes. Students in her class, they would like to know, how do you come back from space?
That's another great question. So there's always a spacecraft that the astronauts are in, right? If they're coming from the space station, they either come home in the SpaceX Dragon or the Soyuz, which is the Russian spacecraft. And those spacecrafts will hit the Earth's atmosphere, traveling at 17,500 miles an hour. And you have a heat shield around the spacecraft that keeps the astronauts in the spaceship from burning up. And then the Russian vehicle has parachutes that land in a giant like desert like environment. It's usually it's like a cold desert in Russia, and they land on the hard surface. The Dragon and Orion actually land on the surface of the ocean, so we land in water. So we can have it a couple of ways, and each spacecraft can be designed either to land with a parachute system on the ground, or we can land in the water. Great question.
Very nice. And thank you for answering that for us. Another question, another great question. This one comes from Billy and Joanna. They're in Miss MJ's second grade class. They would like to know, what do we know about the moon? What's it like on the moon?
So some of the best ways to learn about the moon is to kind of look at some of the pictures and videos of our astronauts when we went to the moon in the 60s and 70s. And because of those missions and the samples of the rocks in regolith is what we call the moon dirt, what we brought home taught us that the moon is just like Earth in a lot of ways. And we believe that the moon was a part of Earth at one time. And there was a major collision with a huge object in space that has sent all this debris from Earth out into our orbit. And eventually it kind of molded and came together to form our moon. And so that was something that we had no idea. You know, that was a really cool discovery during the Apollo missions, is helping us understand where the moon came from. I can tell you, based on what the astronauts say, that the moon dust is very coarse because it's volcanic. There used to be active volcanoes on the moon. And don't think like really tall volcanoes, like mountain volcanoes. There are fissure volcanoes. And so on the surface of the moon, there would be a crack. And then lava would spill out the cracks and fill in the craters. So those really dark spaces that you see in the moon pictures, those are called maria. And that's basically a crater that's been filled with lava that's made of mostly basalt. Which is an igneous rock, like a volcanic rock. And so we know a lot about the area that we explored in the equator region of the moon, but now we're going to the South Pole, and we're really excited to see if there's something different there that we don't know about yet.
Very, very cool. We only have a few minutes left, and there are so many questions. I can tell you this, Miss Alicia, in her class, she has 4th and 7th graders. One of them had a really great question. They wanted to know, are astronauts planning on bringing food, or will they be growing it?
Well, you know what? They're going to do a little bit of both. We're definitely going to be bringing food with us to the moon and to Mars, just like we do for the International Space Station. And then we also want to grow our food. So we've been practicing growing lettuce and small type of plants on the space station for the last several years. And we're going to do the same thing on the moon. We want to set up an area in our base. Maybe it's a greenhouse, or maybe it's just a laboratory where we begin to grow different types of food. So it could be like tomatoes, and lettuce, maybe fruits that are easy to grow. You know, sometimes like maybe strawberries are sometimes easier to grow in a laboratory. So we're going to start off small, and then we hope to learn a lot from our experiments in growing food. And eventually it would be amazing for astronauts to have the choice of having a fresh fruit or vegetable at every meal, and not always having to rely on their freeze-dried or dehydrated foods.
Very, very cool. Thank you so much. We only have a couple of minutes left. I think about 2 or 3 minutes left. Joanna, who is in Miss MJ's class, she's a 2nd grader. She wants to know how long it takes to get to the moon from the Earth.
So with the rocket propulsion technology we have now, it takes in between 3 to 4 days. But hopefully one day we'll have faster rockets and a new type of in-space propulsion that can get us to the moon and Mars faster. But for now, you're looking at in between 3 to 4 days there, and then 3 to 4 days back.
Gotcha. Our kindergartners had a question for you. They want to know, will there be water inside the spaceship?
Yes, we're going to bring our water with us, and we're going to recycle it so that it can be reused. So on the space station, we've learned a lot about recycling our resources. So even your urine, when you go to the bathroom, and we will purify the urine, your pee, and remove the bad and gross parts, and what's left is, clean water. So we recycle our urine so that way we have drinking water. We recycle the sweat and the moisture in the air. And so we're going to try to recycle as much as we can, just because it's more efficient and it's cheaper than having to always have to bring more and more resources, right? And we're going to try out some new systems on the moon to see, if they work similarly as we do in the space station, or maybe we'll even improve them and make them even better. But we're always going to bring water with us. We always have a backup. So just in case, let's say our recycling system doesn't work and we need more water than usual, we'll always have that backup.
Another great question. This will be our last question because we're just about out of time. Some of our students, our 4th and 7th grade students in Miss Alicia's class, they'd like to know how many people have been in space.
So I was looking that one up today, and it's well over 550. And the website that I found didn't give me the number I wanted. This was like in 2018. There were 556. So that's not accurate anymore, right? So it's probably closer to 600 now, since that was well over 3 years ago. So I would say a little under 600, and I'll see if I can find the exact number once we hop off, and I'll try to get that number to you guys later on today.
Very cool. Thank you so much for spending a little bit of time with us. And, that means that we're just about out of time today. I'd like to take a moment on behalf of the Great Lakes Science Center. I'd like to thank you, Patricia, for joining us. Our guest today has been Patricia Moore. She's a communications strategist and museum liaison for NASA's Artemis communication team. It's been so cool to have you here. We hope to see you in person sometime soon.
I would love to come and visit you guys in person. It's been a while since I've been to the Great Lakes Science Center. So hopefully in the next year or so, I can make a trip up there. But you guys have a great day, your last day at camp for the week. And thank you so much for letting me join you.
All right, campers, that's all the time that we have. Thank you all for joining us. Thank you for all the great questions that you submitted. And of course, we want you to stay curious. See you, everybody.